didn't know how to get there. So they asked me to come in and help them figure out what their strategy would be, their tools, their process, and their pipeline. So this is the first presentation I've given of this material, and it's been a real challenge. This was about 3 months worth of work putting together that the talk is based on and helping the client with that. But there's a lot here, and I could give a full presentation on the architectural and design considerations around cloud, or about the tools and technologies used, or even just about the development operations changes needed. For this first talk, I'm just going to speak a little bit about all of those, plus some of the business interests and business ramifications. If anyone has feedback, excuse me, please get it to the organizers. They will get it to me. I do believe Dave Moran has graciously offered to help out with that as well.
Yes.
And then I can tune anything for any future presentations you guys might be interested.
Also, I'm assuming, Tim, as you're going through your presentation and sharing your thoughts, do you want people to wait till the end and ask questions, or do you want us to just have them post them in the chat and then I'll kind of pause, or you can pause?
Yes, great question. Actually, I prefer interaction. I really find it unfortunate we're having to do this remotely. That's the reality of today. But I do like interaction. So if anyone has questions, comments, grammatical corrections to slides, feel free to give it to someone, and feel free to interrupt me, Mache, or I'm sorry, Milan, or anyone else with questions. I don't mind that at all. And then we will have a QA at the end, but we don't need to wait until then.
Okay, great.
So this is a CI/CD pipeline. Excuse me. This is a snapshot of the job that was run for this talk. And I'll try to tie it to what I'm talking about later in the presentations. You'll see this exact same slide twice more. And I'll talk about the specifics regarding it then. But I wanted to kind of start off giving people an idea of the work that goes into getting something into the cloud in a fully automated way. And I do not know why, but my keyboard's not cooperating. One other note, we did notice right before we were starting, for some reason, Zoom is only allowing me to share an application and not a screen. So when I do go to show some code, there might be a slight disruption as I go to switch what I'm sharing. What does cloud ready mean? Like so much software technology, there's no industry standards. Software, and I say this and it upsets some people and other people applaud, but software is not an engineering practice. There are no NEMA standards like there are for electrical enclosures. There are no NTP standards like there are for pipe. There are no UTS standards as there are for screws and fasteners. Thus, there is no industry standard for what cloud ready means. So what I'm going to present today is my definition, which, if not all inclusive, is at least a reasonable starting point. We're going to talk briefly about the history of applications, running them in production, and at a high level, what they look like. To do that, we're going to use this as just a simple application. More specifically, it's kind of a basic, normal business application. We have a user interface. Traditionally, it's going to be a web app. Historically, it might have been a desktop, but most times anymore, it's going to be a web app. It's going to have some kind of generic business service, and it's going to have some kind of persistence store and means of interacting with that. When we went to deploy this application, it wasn't unusual that the services in the user interface were written in such a way that they actually had to be deployed to the same server. And server is a really overloaded term. So in this particular context, what I mean by server is the same instance of an operating system running originally on physical hardware in a data center. And then it would connect through ODBC or JDBC to some backend persistence store. But we also have network considerations. We have things like firewalls, we have things like routing, things like load balancing. And historically, different groups owned these different areas of the application. Operations owned the networking and firewall security. The delivery team owned the application itself, although typically not installing it. That would have been some other group. And then DBAs were responsible for the database. To begin to address things like load, multiple servers are added. Components are separated and deployed to their own servers. As load continues, we need more servers. And this adds a lot of complexity that this graphic is really simplifying. The complexity of what was yesterday isn't necessarily the focus of the talk. But one of the issues that this had was you had, as an organization, a huge amount of hardware in your data center that was idle most of the day. Even for multinational organizations, you would typically have data centers around the world. So your servers were utilized for, some portion of the workday, 8 to 10 to maybe 12 hours. But there's still typically an issue of you can't arbitrarily deploy components. So even though you have a UI, 2 different services, and a database, as load grows, you can't arbitrarily say we need an additional server to run service 1 on. You typically actually have to deploy multiples of these as a group and then load balance across them, which exacerbated the issue. It left a lot of problems around manually managing things like routing. We did get better, and we introduced things like virtualization. Originally, this was to reduce the cost of software development, making it easier for developers to have access to otherwise expensive resources. But this quickly matured into the way we deployed our applications. So this allows multiple instances of these disparate pieces to run per server. But it adds complexity as well. We end up needing multiple VMs, and we need multiple physical machines that these VMs run on. And there's still not to this day a great way of balancing all of that out. And it's also important to understand that adding VMs doesn't actually typically improve performance. It will improve things like resiliency and the ability to deploy multiple clients. Before coming to work for Eliason, I was head of architecture for Snap-on. And one of our expensive processes was processing images. One of our applications required 99 10 gig DVDs to deploy if you didn't have an internet connection. And the vast majority of those were images. So it would take days to process. And my boss, the CIO, when I would complain, would just tell me to spin up more VMs on the servers. This also doesn't alleviate the need to deploy these components typically as a cluster of a UI, a service 1, a service 2. Operations becomes more complex as well in these environments. Traffic shaping starts entering the picture. The same is true for the database, where you might be multi-tenant. You might have your development, your QA, your test, your prod databases running on the same database server. Things were really beginning to be a mess. So back to the definition of cloud ready. When I'm talking about an application being cloud ready or cloud native, what I mean is an application has no deployment dependencies between the tiers, no application-side session management, no interdependencies that would complicate deploying only exactly what is needed one at a time. And this kind of oversimplifies how to deploy such an application. But most of the complexity, won't be talked about today, but some will. And data can be a real issue if you're locked into legacy technologies like large database management servers. So for Cloud Ready, we're talking typically microservices, service-oriented architectures. We're talking things like single-page web apps with Vue.js or React or whatever your favorite JavaScript framework is. We still do have needs for data persistence. And basically, it's just a modern in-tier application. The trickiest thing to deal with here that I really won't directly be addressing today is the data persistence problems. Whereas I'm not a fan of relational databases, they are the reality for most organizations. And they do bring some complications that is easy to address if you work in an organization that isn't locked into a monolithic database server as your technology of choice. So the application that was written for this client to show what that initial pipeline could be and would be was a Vue.js single-page user interface. It was a RESTful microservice up at the top that would just simply return some kind of static data. It was another interactive REST microservice that would persist data to a Mongo database. So this is another definition of what Cloud Ready is. This comes largely from the folks at Heroku, who came up with this definition to help steer customers to their platform when they were new. And there's a lot of important things to consider here. We are talking one code base tracked in version control. We will talk a little bit about version control in a bit, but your dependencies, you're explicitly declaring and isolating your dependencies. You're not only talking about infrastructure as code, you're talking about configuration as code. You strictly separate your build, your run stages. And this has even itself been modernized because apparently someone thought 12 wasn't enough. So here's an updated version from the folks there at the tanzuvmware.com site, which builds along around this. And the things I do want to point out that are, I think, critical here to my definition of a couple of slides ago, where we have the ability to independently deploy components exactly what we need, are things like API first design and architecture. There again, dependency management. Logging is a huge deal. I told a client last week that wanted to talk to me about spinning up an Elk stack to handle their logs, that first of all, they need to learn how to do logging. Logging should be an operational thing, not a business functionality. And that distinct.
A good question, just to kind of, and I don't know, you can tell me if it's good time or not, but you know, Andrew and I were talking about just like how more and more the business is responsible to understand a lot of the stuff, even at the high level. Like, so this is, Andrew was saying, this is probably one of the most technical talks that we've had at Agile Main. And we've had discussions of just how important it is for business to at least understand what you're describing here and how things are changing. And I go back to Bob Fisher's on here too, the talk that he did maybe now a couple of years ago, maybe a little less than that, but about how technical debt is a business problem. So I don't know if anybody has comments, or Tim, you have comments. It's just like, as more and more organizations are becoming technology companies, they don't necessarily have to be, or people within leadership within those companies doesn't necessarily have to understand ins and outs of these things, but just high level.
You're saying several things there that are important. First of all, I'll point out that that presentation Bob gave came out of a blog post that we both co-authored. You just stated that as more and more companies become technology companies, and whereas I understand what you meant, what you actually should say as more and more companies finally realize they're technology companies, that they're software companies.
Yeah.
Because most of them, especially for the people that are going to be on this call, are. Contrast that with when I first moved here to Ohio, which is where I live. I worked for a regional insurance company. And this was back in the early 2000s. And they hired a new CIO, and as CIOs are wont to do to earn their keep, they have these quarterly town halls. And this gentleman goes up to the podium, and the first words out of his mouth was, "We're not a software company, we're an insurance company. I could fire you all tomorrow and replace you with typewriters." And other than the incredible amount of morale that built, I raised my hand and I said, "Excuse me, I don't sell insurance, so I must be working for the wrong company." So business does need to understand this. Business does need to understand the implications of it. And a perhaps shallow and trivial example is the one I was beginning to pontificate about is you interjected, which is around logging and what should and can be logged. This particular organization is in the medical field, and they stated they wanted an elk stack because they need to keep records of communication with their customers due to federal regulations for 7.5 years. So they wanted to use elk to troll through the log files to build these message histories and store them. And I said, from a business perspective, that's wrong. Logging is operational. What you're talking about is an actual business requirement, and that's telemetry, number 14 on this list. But most organizations don't understand that, and most business want to wash their hand of knowing that. And I wouldn't expect a CEO to understand the difference between logging and telemetry, but I would sure expect a product owner, which is supposed to be the business representative into IT, to understand the difference and to understand that a regulatory requirement of keeping information for 7.5 years is a business requirement, not an operational requirement. That's the kind of thing where business does need to be involved in this, and in some cases understand the ask of them for investment in allowing this to happen. Is that reasonable, Milan?
Yeah, I mean, it's just, I'm interested why they're, see, because I'm like, at least what I'm seeing is that more and more companies are hiring people in business that have strong IT backgrounds that understand this stuff.
Yeah, and I think that it would be nice to see that. One of the larger employers here in Ohio is Timken Steel, and they used to be Timken Bearings. I won't go into that backstory, but they have an interesting philosophy of they won't hire C-level officers that didn't come up through the engineering fields in their organization, because these are the people who do actually understand the business. And we are seeing that more in some of the IT fields as well.
Yeah.
And there again, that specific topic, I'm sure that an entire presentation could be given on that. All right, so why be in the cloud? What are some of the advantages? And some of the advantages I think people are going to look at and they're going to think that they're going to read, but I'm going to challenge you because some of the advantages, while they might appear obvious, there's a little bit more subtlety to that. So allows organizations to deliver value much faster with higher quality. That's a really loaded statement. There's nothing intrinsically higher quality about being in the cloud versus not the cloud. And I'll point out now, and there's a slide for it later, but we haven't defined where the cloud is. So we're just saying cloud. So why is this an advantage if it's not intrinsically higher quality? Well, it's because you require that pipeline you saw at the beginning to actually effectively do the cloud. That automated pipeline does improve the speed. In the particular organization I was helping with this, it would take them 6 weeks to just simply get a deployment out the door. Not the development, but just the deployment process. This pipeline, you'll see, does it a lot faster. The quality, because automation requires policy changes. It requires business to have faith that what we put out there this rapidly is not going to come back and bite them due to security vulnerabilities, functional defects, things like that. So it's almost predicated on a lot of automated testing, which there again is a huge topic in and of itself. It gives the organizations the ability to quickly scale up and down. So I would think this one would be obvious, but one of the needs we had when I worked at Snap-on was if an automobile manufacturer had a recall, Toyota just recalls 2 million of their vehicles due to Tata airbag issues. That puts a huge load on the system. It's a spot load. It's an instantaneous load, meaning it might last for a day, it might last for a week, but it's not going to last for months or years. So being in the cloud allows you to respond to that load without needing to go to your hardware vendor with your 9-month SLA to get new servers installed in your data center. Automation is easier in cloud-based applications, and this might not be intuitively obvious as to why either. But it is because when you go to the cloud, it can fundamentally require changes to your design and architecture. And when you start doing that redesign, if you predicate it upon automation, you don't have to overcome just simply the inertia of what was there. So some of these advantages aren't inherent technical advantages. They're available process advantages. You can leverage existing systems and practices, and I'll talk more about that when I talk a little bit more about the example application. And then organizations can migrate the most valuable applications to get those into their hands of their customers first. I'm not advocating organizations go cloud. Start with what makes sense and go from there. There are also some considerations. Your technical practices must be assessed and fixed where needed. Most organizations couldn't go to the cloud if they wanted to. They just simply, even with smart people, it's like Lake Wobegon, right? Everyone's smarter than average at my company. You still don't have the ability to do this. Tools, practices, and securities must be in place. DevOps is an interesting field when we talk about DevOps from a CI/CD perspective. When I got started at DevOps, I was with a company called ThoughtWorks, and we came out with the first automation server. It was called Cruise Control. So this was before things like Jenkins and Circle CI and things like that. But back then, these tools enabled us to do a manual practice faster. They weren't required to do the job. They just allowed us to do our jobs faster and in a more hands-off manner. But as tools improved, process around those tools developed that didn't initially exist. And today, we live in a world where our build systems, regardless of our technology stack, can run our tests as we type. I do this in my C++ code, my Java code, my JavaScript code. So tools are important. And we have some really great tools out there. And then the practices using those tools. I am kind of surprised at the number of companies today that just simply don't lint in their IDEs as standard practice as an example. And then there again, we need to be security first. I won't enter into an argument about DevOps versus DevSecOps, but security is critical, and we want to make sure that's part of our pipeline. And it forces you to automate things and do things differently. So that is an advantage, but it's also a consideration because you must change, you must automate. And the cultural hurdles to doing these things can be significant. You need significantly more managed resources. I actually forgot to put in a slide that spoke specifically to that. But what I mean by this is in kind of that traditional virtualized environment, where you deploy to your VMware instance in prod, you might be deploying to 2 or 3 different VMware servers, maybe a dozen. Let's be, I won't say generous, I'd say ridiculous, and say you deploy to a dozen servers, some for your UI, some for your services. You need to update your database schema. One of the pieces of code I'll be showing you in a bit around this cloud-based application uses Amazon Web Services and creates more than 50 different items in Amazon that need to be tracked and understood. There are security, there are compliance, and there are cost considerations to all of that. And it can require significant changes to the business as usual. A lot of organizations really struggle with transformation, whether it be an agile transformation, a DevOps transformation, digital transformation, or what have you. And my personal opinion is one of the reasons they really struggle is because they try to take little pieces at a time and move along. But change is hard. That's kind of a tautology. And when things get hard, it's kind of human nature to revert to our historic practices. If I was doing something yesterday and I didn't get fired for it then, why would I be fired for it today? So if I can't do this new thing, I'll just do the old thing and maybe use the new nomenclature. That doesn't work in going to the cloud. It does require a fundamentally different design and architecture. So back to it all just works. So this pipeline has 30 steps. It really should have more, but this has 30. It runs in 41 minutes. And as you can see, it's all green. And this actually takes code from when a developer checks it in, deploys it to a production-like environment. So in theory, it could be customer-facing production. And it all just works. And that's good because the sound pipeline is the core of everything. Without this type of automation, containerization, infrastructure as code, configuration as code, auditability and compliance, they can be an even bigger nightmare than when you're not in the cloud. And a pipeline, even for non-cloud apps, is critical to the concept of continuous delivery as a business decision versus as a technical limitation. And what I mean by that is when I go into an organization and start talking about CI/CD, where there again, my definition of CD is a developer checks in code, a deterministic amount of time later, it's in production with no manual intervention needed. Organizations will often say, we can't do that. We're different. We're heavily regulated. We're whatever you might want to fill in the blank. Those things may be true. They're often not, but they may be. At the end of the day, however, whether or not you do this, whether or not you adopt CD as I defined it, should be a business decision. But it's not. Often it's a technical limitation. A business couldn't do it even if they wanted to. But this also is the end of the story. It's not the beginning. At the beginning, of course, none of this works. None of this is green. So let's get back to our sample application. So we're going to talk about containers for a moment. I don't know the background of the people on here, so I have to go into at least a little bit of all of this stuff. A container is basically just an operating system image with an application installed into it. This is wrapped up into a package, and it can be spun up just as you would spun up any other virtualized image. For those of you who remember things like Ghost, although VMware actually existed before Ghost, or Parallels, or what have you. But the intent of containers and their ecosystem is fundamentally and radically different from other types of virtualization. Containers are ephemeral. From a practical perspective, this means that once you stop one running, it goes away. You can't restart it. From a design perspective, this means you want to package just one thing and consider the package itself to be the deployable unit, not the application. It's not your application you're deploying, it's your one piece of your application, the operating system, dependencies needed to run it. And this can seem a subtle or confusing thing, as the ramifications of this aren't necessarily intuitively obvious. But for now, I just want you to take from this that a container is never upgraded, fixed, or interacted with. You don't log into a container and upgrade your application or patch a firewall issue. If a defect is found, you start the pipeline again, you create a brand new image, and it's that image that gets redeployed. To do this, your pipeline has to be fast, it has to be efficient, it has to be able to do this in a timely manner. And I should really mention that containers, when misunderstood, don't provide a benefit. They can actually provide a detriment. One of the clients I was at when I started going in the door, I attended a meeting and they were thrilled that Amazon was rolling out a new version of their service. And I asked why, and they were like just ridiculously happy. And I asked why this was. Was there some, new, serverless technology they wanted to play with, image, what? And they said, no, they're finally allowing us to have more than 1,024 IP addresses per Docker image. And that just kind of left me speechless. And what they were doing is deploying everything to a single Docker image. So they were basically using Docker as a replacement for VMware. That is not what a container is. And that kind of usage, which can come out of a mindset of this lift and shift mentality, is actually going to cause a lot more harm than good. So now I'm going to talk a little bit about the technologies I'm using. These are kind of the preeminent technologies in the industry. Around containerization, we have things like Docker, Kubernetes, and Helm. Those are complementary. Those aren't either or. You have your cloud providers like Google and AWS. Those are either or. For provisioning of infrastructure, either locally or in those two cloud providers, you have things like Minikube, which is for running locally, like on your development machine. You have Terraform and Rancher. And then kind of ancillary, you have things like Let's Encrypt. I really love Let's Encrypt. I've worked at organizations where one of the pains of deploying an application to production was the management of SSL certificates. I actually have personally worked at an organization where a developer used their personal credit card to charge $3,000 to renew an SL cert because it had expired. The application was down. And of course, going through procurement would have been 3 months. Things like Let's Encrypt are free. They're absolutely secure. Every single browser in the world supports them, and they can be baked into your pipeline to make SSL just go away. It's a non-issue. And then companies like GitLab, CircleCI, GitHub, Azure DevOps for hosting your Git repositories and doing your pipelines.
So Tim, we did have a question posted,
Yes.
Bob Ellis, in the chat. So Bob, did you want to jump in at all, or?
Yeah, sure. Hey, Tim.
Hello, Bob.
Just some of the other value reasons in terms of going cloud. I was wondering if you would add maybe some discussion around a lot of the common reasons that I've heard amongst clients are things like modernizing the legacy infrastructure, moving off a mainframe is one. Multi-vendor model. So obviously, if you can move off of a mainframe, would give you different vendors. Another commonly, maybe these are myths, maybe they're not, costs. And then the other one would be just speed of development, effectiveness of development, because you're able to use all the modern tools and modern technologies.
You threw a lot of different things there, so I'm going to try to respond to them as much as I can. If I miss any, remind me. I'm going to tackle the one that's stuck in my craw, and that's cost.
So, Tim, so if you want to open the chat window, you can reference it there too if it's easier. I don't know.
Let's see here. And unfortunately, I really don't know where the chat window is.
On next to the screen share.
On my Mac, it's not. That's all right. I'm not gonna take the time to find it at the moment.
Bottom center on the Mac.
My bottom, I've got mute, stop video, security, participants, new share, pause, annotate, remote control. That's it. So I apologize for that, but that's what mine is showing. And it could be because I'm the presenter. I don't know. But so cost. Yes and no. Yes and no. Cost can be less. You heard me say earlier that organizations, it's not uncommon for them to have millions or tens of millions of dollars of hardware, and that often sit largely idle. It's not uncommon, even in a customer-facing, production-used application, that resources are only utilized, the 15 to 20% range. So that does imply that most of that is sitting there idle. There's some gotchas, and I'll come back to the gotchas when we get to where the cloud is. We had a client call us up. They were using Amazon. They were happy with Amazon. They were spending $40,000 to $50,000 a month. And 1 month they get a bill for $2.1 million, and they have no idea why. Now, if anyone's ever played with the cloud, set it up, billing against your credit card, it can be a terrifying thing. I still have an argument with Google where I get a bill on one of my Google Cloud platform every month for 2 cents. And I have called them now 5 times to complain about this. And they're like, okay, we'll refund the 2 cents. I said, that's not my problem. I said, my problem is I have no idea why you're billing me 2 cents. They said, well, because you owe it to us. And I said, okay, please show me what I have done that has incurred a charge of 2 cents. Well, we can't. And I said, well, neither can I. So how do you know I owe you 2 cents? Well, because my computer tells me. Now, all of us will probably be very relieved at that because computers never lie. They never have defects. So if the computer says I owe them 2 cents, I must owe them 2 cents. So for me, I've stopped arguing with them. My time is valuable enough that the principle of the matter is just no longer relevant. But if you were that company that instead of getting a charge of 2 cents, gets a charge of $2.1 million, and you have no idea why, that's a serious concern. The modernizing, yes, that's absolutely so. There again, you heard me say that my definition of cloud ready is no server-side state management for applications. Yet most business applications today still insist on server-side state management, even when they're using things like SPAs. And so you have to kind of modernize when you go to the cloud, because if you don't, it becomes a logistical nightmare. It actually will end up causing you more production outages, more defects than not being in the cloud. So if an organization isn't dedicated to upskilling their employees, which means sending them to training, it might mean bringing in some experts to either help them on a temporary basis or to supplement their staff, permanently, it can be a problem. And because I didn't have the notes up, what were the other things, Bob?
I think modernizing the was really a catch for all for the others.
Yeah, modernizing. There are several aspects to modernizing. I'm shocked at the number of organizations out there. And please, if any of you fall into this category, I'm not trying to make fun of you. I understand that we all don't necessarily get to choose these things at the places we work. So I'm not trying to make fun of you. I'm trying to make fun of your employers, perhaps. But I'm shocked at the number of companies out there that are still using Java 1.8, for example. And these companies will have entire projects around upgrading to the latest version of an operating system. But it's actually not even usually the latest version. It's not uncommon in organizations I'm in where they will have an entire, 2-man-year project to upgrade to an operating system that is end of life last year. And I'm like, you're upgrading something to end of life? Well, yeah, but it's because the one we're currently on hasn't been supported by the manufacturer for the last 5 years. So when you go to the cloud, one of the things you should be doing is, as I said, a container is a deployable unit. That is the operating system, the libraries, whether that be Java or .NET or libc++, whatever. That dependency management is built into the platform to help you keep those current every single build, at a minimum every single sprint or time box of your choice. But they don't languish. You would never have in a cloud-based world, you would never have a project to upgrade an operating system or a version of Java or a version of Vue.js. It just happens on a daily basis. And that's huge from a security standpoint and from a defect standpoint. As vendors release fixes to their products, we want to adopt those as rapidly as possible, right? The Equifax data breach is the ultimate example of that. They were using a known vulnerable piece of software that was 12 years out of date. I've ranted on that probably enough. If there are other questions or points, I'm sure that they're valid, and I'm sure I would have something to say about them. All right, so we're back to Docker. And I don't, this is where I'm going to start trying to show other things. So what I want to show now is just simply what a Docker file looks like. So let's see here. I'm hoping you can see an editor.
Yes.
Yes.
So a container, a Docker image, is created from a text file. That's all it is. It's nothing special. This is what one looks like. This is saying that we want to use as our base operating system, one provided by Microsoft, their .NET Core, for ASP.NET version 3.1. Let's see, Microsoft for that, I can't remember if they're using CentOS or Ubuntu or whatever, but they're using one of the Linux for this. And then we say, from this, we're going to run this command. So basically, this is downloading an application into the Docker image. And we say, when a Docker image runs, when you start it, you're going to execute the application.net, passes this command. That's it. That's all a Docker image is. You then run a Docker command from this. It builds the image, and you would publish that image to your Artifactory or Sonatype Nexus, whatever your image repository was. So now I'm going to switch sharing again. So in this particular application, we have Docker images for the Vue.js SPA, for these two microservices, and for MongoDB. You can run a Docker image. You typically wouldn't in production. You do typically want to run them on your development machine. And you can. There are technologies like Docker Swarm and a couple of others that are similar that basically let you federate running Docker images. But for the most part, the industry as a whole uses Kubernetes. It is a pretty nice service. So now we're going to take a brief look at Kubernetes. Let's see here. I want that one. So this is a Kubernetes file. It's a YAML file. YAML, if you're not aware, is a serialized object format. They are ridiculously picky on formatting and indentation. You definitely do want to use lint tools to help you with this. But this is just basically saying that this is a development. We're giving it a name. We're giving it a strategy of this rolling update. And what things like that means is we can see that we have two replicas. That means we want two images. We want two VM equivalent, if that's what you're familiar with. We want two instances of this running at all time. That way, if one of them crashes, the other one is still there. There's no interruption of usage. And if they're updated, use this rolling update. Let's see here. We specify what container use. This is the Docker image. We want this Docker image. This is the location of the Docker image. And then we just specify the port we're listening on. Most of our applications are going to be 80. What's nice about this is if you're writing a J2EE application where the default port might be 8080, you can still expose the container port of 80 and have it internally listening to 8080. Makes it really nice. We give it 15 seconds to start up before we start this liveness probe. And what this will do is this will say every 20 seconds after the first 15 seconds, we will do an HTTP GET to this resource. And if it doesn't respond, we will kill the operating system and restart it. And this is how Kubernetes can make sure that your applications are always available. Kubernetes manages the running of your applications for you. So this is what defines a Docker image in Kubernetes, but then we can create a service. This is what a service looks like. It's not hugely interesting, but what's important about creating a service in Kubernetes is that's what will give you load balancing between them. This will actually cause a Kubernetes pod to be created. It will spin up by default Nginx is a reverse proxy load balancer. So based upon how many replicas you have running here, it will load balance across that many. So if I had 3, it would round robin against 3. And you can change this based upon anything you need to do to manage a particular load or desired outcome. And back over to the slides. So now I want to talk about who owns what and where, because I just showed you code that quote unquote creates infrastructure or manages infrastructure. And I'm using those terms generically. There are operations people listening, don't smack my hand. I do realize it's a bit of an overstatement. But about this time in working with an organization, if not before, people start asking the questions of, well, who owns the responsibility for creating these files? Who owns the build? What source repository do they go into? So now what I'm going to share, the same editor. One of the things I like about Cloud First is if you look at the best practices that are developed around this, everything required for the application goes into a single repository. And I'm using Git, but it could be Mercurial or whatever your favorite SCM of choice is, as long as it's not ClearCase. So everything lives in that repository, the Docker files, the Kubernetes files, and that makes it clear that the team at the end of the day owns responsibility for this. If I am a developer of an application and I require a microservice, I write a microservice, and my microservice requires a database, it's my responsibility to make sure that that database is there. That's what Kubernetes is helping me achieve. So by putting it in that repo, it makes that clear. So technically here I have 3 repositories, and this is probably the easiest one to talk about. This was that quote unquote external service. So this external service could be a microservice that you either get from a vendor or you could get it from a different team. But the intent is this was a microservice that your group doesn't actually create, it just simply consumes. So this is a pretty easy one. This particular client was using .NET Core, so the stuff is all in .NET Core. Now, what is interesting here is there's nothing in here about Kubernetes. There is the Docker file, and there's nothing in here about Kubernetes because this never gets deployed independently of an application that uses it. There are not some cloud of the service out there running that I consume. It's actually deployed as part of my application and part of my Kubernetes control. So this is just strictly the service. Now it does have its own pipeline. It does its build. It does its security scans. It does its static code analysis. It publishes to Artifactory. That's all this does. This is the main application where we have the user interface and then the service this particular team writes. And it has its Docker files. And then it has this deploy directory. And under here, we have Helm and we have Terraform. We'll talk more about those coming up. But Helm deals with the Kubernetes side of things, Terraform with the provisioning and installing of things. I think that's all I wanted to say about that for now. Okay, so what goes into the repository? Well, like I said, everything. Your configuration, your environment files. Ansible can be used in this mix as well. So if you're using Ansible, your playbooks would go in here. Everything that is required to get value. One of the things I've been talking with customers more and more about, and so have a couple of the people I know on this call, is outcome versus output-based delivery, where teams aren't measured by how many user stories they can get through in a sprint. It's what value those user stories in production are bringing the organization. And I'm not talking about profit sharing. I'm simply talking about the code that we write, either ourselves or the teams we're part of, isn't valuable to the organization we work for until it's in production, until somebody's using it and paying for it to be there. From that perspective, everything that is required to achieve that is in our team's control should be in that same repository. So absolutely the application code, configuration, absolutely. One of the things to really come out of originally the JavaScript world is pretty ubiquitous now, which is where you no longer hard code configuration parameters in your Spring context or what have you. You have multiple environment-based configuration files, one for your local machine, one for whatever environments you might have, and then when an application is executed, based upon either a command line argument that is templated or an environment variable, it reads those configuration files. The infrastructure configuration, what is the networking? What is the firewalls? What is the load balancing? So who owns the pipeline? The team owns the pipeline. If you're in an organization that has a DevOps team, you don't understand DevOps. The team owns that the build is green. If you have a DevOps team, so I spoke perhaps a bit too broadly. If you do have a DevOps team, they really should only own the infrastructure that pipeline is running on. So if my build breaks, unless it broke for an out-of-memory error, and perhaps even then, it's the team's responsibility to fix it. I just spoke about the DevOps team. It might not be uncommon, like I said, if you're using something like Jenkins, Jenkins itself needs to be administered, run. That's what a DevOps team should be doing. You will have a SecOps team, and we'll come back to them in a bit from a code perspective. But it will be common, especially if you're using things like Docker, that your SecOps teams are the team responsible for providing the base images your team uses to install their applications to. And I'll show an example of that later. So the delivery team, there again, if I write a piece of code and I say, I have no idea how to run this code in production, how do I know that the code I wrote meets the business's requirement? More and more organizations are adopting definitions of done. That definition of done is sign off in a production-like environment, whether that sign off happen automatically through a pre-approved set of ATDD tests or some manual intervention on the product owner's half. That means it's the team's responsibility. So what about the separation of responsibilities? And separation of responsibilities can mean different things. In a lot of organizations, I'll hear things like, well, Tim, we have to have two sets of eyes on anything. So we can't do automatic CD because if a developer commits code and it ends up in production, well, there's no second set of eyes on that. Or, you know, we need to make sure that security has approved everything in there so that the developers haven't done something nefarious like change the base image to include their personal cryptocurrency mining application. And so this is how things like that are done. You have your application Docker images, and then you have your operational base images. And the operational base images are the ones that your SecOps team or whatever nomenclature your particular organization uses to manage those things. So an example of that would be, we have this repository, enterprise infrastructure as code. This would be a repository that would typically be in your operations team, your SecOps or whatever your organization calls it. And we see that we have this build images and deployment images. Build images are the Docker images that the pipeline uses to execute. Things like Jenkins, Azure DevOps, Bitbucket, CircleCI, Travis, they all require you to specify a Docker image to spin up to build your application. So what one of these looks like, for example, is this. This is a more realistic Docker image. We're still starting with this Microsoft .NET Core, but we're adding things to it. We're adding things that we need to build software, NPM, Python, Unzip. doing all the configuration of this. So it's reasonable that the SecOps own that this file exists. But we're going to come back to even that concept later. And then we have deployment images. So these are the base images that would be used to deploy an image. This would be one used to deploy a view image from Nginx, right? Most single-page web apps only need Nginx to run. So this would then be the base for that. If you were on a .NET Core, this provides the official .NET Core. And then in your application, we can see that this is my application deployment view file, and it uses as its base that sanctified view from this other repository. And then we do what we need to do to run. In this particular case, we need curl. And that's why that curl was included there, by the way, on this one. Yeah, so this is installing curl, and someone might say, well, why do you need curl to deploy a view app? Technically, you don't. What you need curl for is to interact with Artifactory to pull down your artifact from. And then we expose port 80, we install Nginx, and boom, we're good to go. So that's how the security separation of concerns is handled. The two sets of eyes are handled by pull requests. Every organization should be using pull requests. And part of a pull request is a code review. So when I say that when a developer commits code, it is in production in an automated fashion is a slight misnomer. It's technically when the pull request is merged, right? Because a pull request can have things that the developer has to do to remediate defects or design issues or what have you. So it's from once that PR gets merged that pipeline automatically does the rest. So let's see here. So now we have Terraform. So Terraform, Kubernetes needs compute resources to run. It needs CPU, it needs memory, storage, networks. Terraform is what's used to provision all of this. And it does it differently based upon your underlying cloud provider. It kind of abstracts that out, whether you're using DigitalOcean, which is IBM, or Google, or what have you. Cloud providers do have their unique resources, and Terraform can interact with those. Rancher is another option. Rancher can abstract all of those from you, and you don't have to deal with it. And I'm sorry, Milan, how long do I have to talk to?
So we're scheduled to, is it 7 o'clock Eastern time? So you still have, I would say maybe like 15, 20 minutes.
All right, so
we should probably leave some time for questions. And
okay, I'll pick up the pace then. So I just want to briefly show Terraform is here. So Terraform is in this repository. And you can do this a couple of different ways. The way I have this set up here is using Terraform. We have this is using Rancher. I have two different options here for Amazon and for Rancher. The Terraform code can be created as a module. Those modules can be published to Artifactory, and the team can pull them in. So that's how you've got your SecOps involved, things of that nature. This organization didn't want to do it that way. They actually wanted it all here. They really liked their idea. And how they get their separation of concerns here is that their Git repos are set up with a trigger to where when anything in the deploy Terraform changes, or anytime a Docker file changes, someone in SecOps is required to be an approver on the pull request. And this is how you can make sure as an organization that a developer either intentionally or unintentionally doesn't do something nefarious or circumvent your security considerations. All right. So from an ownership and responsibility perspective, it's all the team's repository. It's all the team's responsibility. And you want this internal open source model, which is something else I talk a lot about. So in this particular case, these base images might live in a repo that is owned by operations. That's totally fine. but it should be readable by any developer in the organization. If your Git repos are not set up by default to be readable to the organization, that's unfortunate. And the internal open source model says, well, if I now need something new in one of these base images and operations doesn't have time to get to it this sprint, I should be able to create a branch, I should be able to make my changes, and I should be able to create a pull request. It's much easier for them to approve a pull request than it is to do my work. So that's what that internal open source model is about. And then the pull requests are what protect your organization. So one of the things that I wanted to talk about here briefly is in this internal open source model, it might be the case that someone is going to be worried, well, if anyone can add things to these base images, we're going to end up with a lot of things in the base images. How do we keep this internal open source model from being a burden? That's a reasonable question. That's what the pull requests are there for, and that's what I mean, pull requests to protect the organization. The person who is involved in a code review should have an understanding of the architecture and the design intention behind the code that's there. Google famously does this by an owners file. Their repos at various positions have a file called owners. And by the way, Git supports this. They don't call it owners. I forget off the top of my head what Git calls it. And then when a pull request is created, someone in that owners file has to be one of the approvers, and then there's another approver required as well. So if someone is wanting to add 50 things, well, no, that's not reasonable. Had you considered this alternative? Oh, what you wanted is over here already. Perhaps you should use that one instead. So the point of a pull request isn't simply to look to make sure that all the T's are crossed and the I's are dotted. It's to make sure that the pull request is meeting the design and architectural guidelines, standards, and intentions of the organization. So where is the cloud? Public cloud, that's what most people are familiar with. Amazon, DigitalOcean, Google, Redshift, whatever. But we also have more and more of an opportunity today for the private cloud. So private cloud can be Rancher on-prem. I would recommend that as a great starting point for organizations that already own, not lease, but already own their infrastructure in a data center. They can take a few machines, put Rancher on it, start playing with it. Rancher is from HashiCorp. Most companies do business with HashiCorp. HashiCorp does Vault. They do Helm. They do quite a bit in the open source world. At the end of the day, most companies are eventually going to, the other thing you can do with private cloud is Amazon, and they're not the only one, but Amazon offers a product they call an outpost. So Amazon will actually ship you a rack of computers for you to install in your data center that has every single product Amazon has in the cloud that you can then run in your data center. That's a very powerful paradigm as well. But most organizations are going to want a hybrid version. You're going to want the public cloud because that might help you be geographically closer to your clients for things like performance, for handling spot needs as requirements go up and down. I do think at the end of the day, most companies are going to want development to be in a private cloud, and that's going to be control costs. Controlling costs in cloud can be very difficult. Terraform does have a feature that is a commercial feature where when you create a Terraform plan, it will actually estimate the cost to run that plan on a per hour basis. That's a very powerful feature. I don't know how accurate it is. And we are getting almost done. So now I want to talk a little bit about audit and compliance. You want to automate compliance into your pipeline. I call this continual compliance. If compliance is built into your pipeline, it makes it easy to withstand an audit. And we've talked about the separation of responsibilities. One of the reasons you want this internal open source model is oftentimes developers, if you're like me, you're reading whatever your favorite news feeds are, you'll find some vulnerability in something. You need to act upon that quickly. So if I can change that, create the pull request, I have this audited separation of concerns with multiple eyes involved. And you want to create a narrative for audit. I had a discussion earlier today, as it happens, with someone around why, if you're not using something like Artifactory or Sonatype Nexus, you would never survive a security or compliance audit, because you have almost no ability to show where your artifacts came from, how those artifacts were created, and who put them into place. So by building a narrative for audit, by showing them this is how we protect against this, that, and the other, by showing them that you were thoughtful, every time I've sat down with auditors, they're like, wow, this does more than we could ever hope for. And that's happened in the medical industry. It's happened in the finance industry. You want that narrative. The last thing I want to talk about, I love it when someone says we can't do this because of SOX or SOC compliance. For those who don't know, SOC came out of SOX, and SOC 2, there's SOC 1, 2, and 3. SOC 2 specifically deals with SaaS offerings in the cloud. These do not prevent you from doing anything. As a matter of fact, neither SOX nor SOC require you to do anything, but have a process and you follow it, just like an ISO 9001. So SOC does not tell you what to do. You tell it what you do, and then say that you follow it. Now, it might be that if you have customers might require you to conform to an independent list of these things, and that's fine. But at the end of the day, even though stringent customer-provided compliance can be met in a totally automated fashion. So back to the pipeline. One of the things that's really interesting about this is you no longer have tiers. You no longer have environments. You don't have dev, you don't have QA, you don't have test, you don't have pre-prod, you don't have stage, you have prod. When I worked at Snap-on, not including a developer's workstation, there were 22 environments your code went through before it reached a customer's hands. The cloud is not the way you do that. You do things like blue-green deploy. You spin up these instances. You do your testing. And if you want to do manual testing, that's great. That doesn't mean you can't do that. But the great thing with Terraform is you can run Terraform, you can run Helm, and you can have your exact same environment, non-customer facing, for you to do anything you want to with. And when you're ready, you can either use Helm to reinstall it into your existing provisioned infrastructure, or you just simply use your F5 to make your blue your green environment and your green your blue environment. So blue-green deploys are what companies like Google does. Google, they do it for reasons other than that. At Google, when I was on the Google Maps team, when we went to install Google Maps, that's simply getting the software under the machines that run it, took 23 hours. So you would run the install. Once the install finished, roughly a day later, you would switch that from the blue environment to the green environment. The other really powerful thing about that metaphor is if you switch your blue environment to your green environment and a customer says, oh my gosh, something is broken, you can instantly switch back to the blue environment and get them back to a known, stable, and running application. And the pipeline is crucial. Obviously, I glossed over a lot of the stuff, showed it at a very high level. We didn't really get to play with things running. You can see from here, though, that things like Terraform can take 8 minutes to run. Helm itself can be fairly fast, a couple of minutes. But how would you do all of this manually? If you were deploying to 50 different Docker images, this sample application, even when run in Minikube, creates 2 Docker images for the UI, 2 Docker images for the first service, 2 Docker images for the second service, 6 Docker images for the HA NoSQL database, 2 Docker images for the ingress Nginx controller, a Docker image for the SSL cert manager, another Docker image that will automatically update your IP address if you're using things like Route 53 or whatever your DNS provider is. So even on my Mac laptop, how would I manually spin up 40 different Docker images? that would be insanity. So it can just work. It can all be green, but the statement, it can all just work, doesn't mean it doesn't require a significant amount of blood, sweat, and tears to get you there. It does. You have to put the effort in. One thing I do want to note about this, I did this for this particular client. Let me see if I can get back to the reason why I did this way with these Docker images. Wow, now I regret all of those transitions. Let's go back to this one. So with this example application, these are just Docker images. I showed you what a Docker image was. It pulls down a binary from Artifactory. So this was not throwaway code. This was code that is a template for almost any business application most of you are likely to be using. You could literally clone my repo, change the Docker image from pulling down my Vue.js to your Vue.js, and it would just work. That's a hugely powerful thing. It goes back to Bob Ellis's statement about some of the benefits. You really can use this as an accelerator to get your organization over the hump of modernization, because once one team has got this running and you can show them that it's running, it becomes more trivial to begin to just use this as a template to put everything else into. And with that, now we'll go to Q&A.
All right, so questions, thoughts?
So Tim, one thing, as you talked about this, I've worked with people, and I think, you're talking about an investment here, right? Is to get in your cloud native application. It's not so much what I do see, and you use this term, lift and shift. So I think people tend to get into, I'm going to lift and shift. I'm going to containerize an existing application and port it to the cloud. And then I'm going to have some magical benefits around cost, scaling, resiliency, and other things that because of the nature of being in a cloud. But there's a lot more to that.
Yes.
So I think there's definitely some conversations that absolutely need to be had, and both on the business and technical side, to set expectations about what it'll take to get there and what it means to be there in terms of cloud native versus just a lift and shift.
And obviously, it goes back to my statement that software is not engineering. Every application is bespoke. Even if you're using the exact same technology stack I just showed you here, your application is bespoke. It will do something that would need to be tweaked for what I showed. But for the company I did this with, there was myself, a developer, and an operations person. We did this in under 3 months, and that included beginning to port their existing application into it. Now, their existing application was already set up to use microservices. It was already set up to use Vue.js. They were just simply deploying to VMs. So going from a clean VM deployment to this was 2 weeks worth of effort. And for you, it might not be 2 weeks, it might be more. But yes, it does take some thought, it does take some planning, and it does take some, what do we need to do to be able to achieve that?
I think that's the big question too, because when you talk about added compliance, like changing things on the business side, like with large organizations, with government, that's like, I don't see that happening anytime soon. And people don't have the perspective that if you don't change some of these guidelines, policies on the business side, that you really can do this stuff.
Well, and government kind of is in a whole hell of their own. That really does complicate things, right? Because they actually do take things that at your organization or my organization might be policy, and they make it federal law.
Yeah.
And there definitely are things that are tricky with government, and that's just a can of worms that we can't get into here. But we have customers that are using the most sensitive medical information on American citizens that are doing exactly what I just showed you. They are putting it in the cloud. They're putting their data. It is secure. You just have to understand security. The challenge is getting the people in an organization to do that. My experience has been, though, that the biggest challenge isn't the people that need convincing, it's everyone between you and them. So, as I've stated, when I can actually sit down with auditors, with compliance officers, explain to them what's going on, back it up with the references that show that, they're like, yeah, great, sign me up. What I find interesting is a lot of organizations, when I first do this, it's the teams I'm working with, it's the IT management I'm working with saying, well, we can't do that. Well, why not? Well, that's not our policy. Okay, can I see your policy? What do you mean? I said, well, you're telling me I can't do this because you have a policy, you have an audit requirement that says you can't. Would you please show it to me in writing? Well, no, it's not in writing. Everyone just knows that's what it is. I don't know what that, so that's actually the challenge, usually more than the actual people who get to say yes or no, or the people who think they get to say yes or no. And
So
yes,
there's
that
kind
is
of
a
like two
cultural issue.
questions here from Anthony and Bob that are related to that. Anthony's question is related to the earlier point around what's one of the most important things for business people to understand?
That it's possible. Believe it or not, the most important thing for a business person to understand is that it is possible, that it can be secure, that it can be shown to be defect-free for some definition of defect-free. That gets into that whole testing, which is another can of worms.
Yeah.
And that they can feel comfortable. What is nice is that as companies are investing in this, there are beginning to be more and more use cases out there that show precedent. So companies that are, I won't use the term risk adverse, that's not risk adverse, that's psychopathy. They're beginning to be a little bit more trusting in some of these tools, technologies, and approaches as they see that the wildebeest in front of them has done it and the alligator hasn't consumed them.
Yeah. And
Tim, quick question. One thing I didn't hear you talk on was the decoupling of deployment from release and deploying incomplete functionality that's not ready to be released yet. So how are you managing this from a feature toggles? Is that
yeah, so you mentioned two different things there, the decoupling deployment from a release and then incomplete features. So the first one is the blue-green deploy as an example. The second one would be feature toggles. Feature toggles, thou be dragons. You need to be careful with feature toggles. They can be very powerful, but they can also be a huge thorn if done improperly. But yes, that's how you would typically achieve those two things.
Great. Maybe we have a couple more, and that's great to hear, Catherine. Maybe you can share a latest session, what you guys are doing. There was a question from Bob Fisher related to the question. So Bob's question is, how much time did you spend of that addressing you can't do that here issues? So I think Bob was referring to...
Well, unfortunately, with this particular instance of this particular client, until the very last day I was there, that's going to be an organization dependent question. It's going to depend upon the people involved and their commitment to getting things done versus wringing their hands about whether it can be done. And it's easy to say that, and I know that it's excruciatingly hard to overcome that. I don't mean to trivialize it. In other organizations where I have successfully had that argument, typically once you, like I said, you get to the audit, the compliance officers, whomever, it's a couple of hour conversation, and maybe you go away with some questions that they had and you bring back some documentation. But in the one organization where it was really successful, it took 6 months to get to actually talk to the security, the audit, the compliance folks. But once I did, it was 3 hours, and they were thrilled because now their jobs were going to be easier, because all they had to do is come in and look at your pipeline that it hadn't deviated, instead of manually checking and asking you to verify each thing. Because when I say you build this narrative, one of the things in that pipeline that I didn't really talk about because of time is how you can't get around it, how you can't not do exactly what it is, because it's automated. It's out of your control.
So what is it? I mean, is it like just communication? Because if everybody has the same goal and
It's,
we're all like, what is it that really, what's the most
well,
common theme across of it?
so it's communication, and believe it or not, I think probably one of the biggest challenges to overcome is meaning IT, our comfort with this. Most organizations I know, our comfort would be such, I don't know that I trust our processes. I don't know that I trust our testing approach. So if we actually take it to business and they say yes, oh my God, now we actually have to deliver. Now we actually have to step up.
So yeah, I guess it's, you say comfort, I would say it's trust, which you kind of
Trust.
reference within the but it's really the trust issue. And
Yes.
that's probably like, so trust and communication, that's what I see too, is
And that's why, you know, you mentioned that technical debt is a business problem. You know, in that talk, and I gloss over it here, it's crucial that our business are our partners. They're supposed to be on our team, right? If you're doing Scrum, that's what that product owner is supposed to be. Now, that's not the security, the audit, and the compliance, but they will know the people to talk to. They will know the people. They will know the channels that you would go through to realize this, versus just to simply escalating it to a manager somewhere and waiting for them to figure out what to do with it.
yeah. Great. And thank you, Catherine, for sharing that. And we'll see like next time we do, or what the opportunities. And again, as I mentioned at the beginning of this session, please let us know what other topics you would like to hear. But with that said, we're at time here, and I would just like to again thank Timothy for taking the time out of his busy schedule, and Eliason for allowing him to spend the time to prepare all this stuff, because I know it doesn't, you know, it takes time. So thank you very much, Tim. Thank you.
And the last thing, you're welcome. The last thing I want to say and interrupt you real quick is several people, you know, Dave, Milan, they know how to get a hold of me. I think Dennis Crowley might be on this call. Feel free to reach out to him, bug him. He knows how to get a hold of me. Usually beer's involved. But yeah, absolutely. If there are questions, concerns, anything like that, I'm more than happy to talk with people about them.
Yeah, great. Thank you for doing that. And I know you enjoy good food too, along with that beer.
I miss Portland.
So thanks everyone, and again, we'll probably looking at sending out an email about upcoming sessions in the next month or so. So keep your eye for those emails as well. So thank you. Have a great evening, and see you next time.
Good night, everybody.
Good night.
Be well.
Good night.